Hey you guys, and welcome back to my channel. In today's video, we're going to be learning a new standard. We're going to learn how to identify a pattern in order to calculate the sum of fractional parts. So that means I see the word sum. I know I'm going to be adding fractional parts together. And we're going to be identifying a pattern while we're adding. Remember, a pattern is a repeated decorative design. And our strategy for today is going to be the expanding my units strategy. You'll see what I mean when we get started. Let's go ahead and look at my first problem. I'm going to write the first problem on your screen. I want us to look at this problem together. 0/6 plus 1/6 plus 2/6 plus 6/6. These three dots let me know that my pattern continues all the way to 6/6. So I know that in this equation, I'm missing fractional parts. Do you know which fractional parts I'm missing? That's right. I'm missing 3/6 plus 4/6 plus 5/6. So the strategy that we're using today is called expanding our units. We have to expand our entire equation in order to make sure that we have every single fraction represented in our equation. So 0/6 plus 1/6 plus 2/6 plus 3/6 plus 4/6 plus 5/6 plus 6/6. And we still don't know what the sum is quite yet. You guys, I know that in each of these fractional units, my denominator is 6. So I know that I'm just going to focus on my numerator. We know how to add fractions together. All we're doing is just adding the numbers at the top of our fraction or our numerators. Go ahead and add your numerators together now. Did you get 21/6? If you did, awesome job. And I know some of you guys probably even took it a step further and you decomposed. What did you get on the left? Good job. 18/6. And what did you have left over? Awesome job. 3/6. And I'm sure you guys already beat me to the punch. 18/6 is the same thing as what? It's equivalent to what? Good job. 3 wholes. So this entire fractional unit, or this entire equation of fractional units, equals 21/6, or 3 3/6, or 3 1/2, because 3/6 is equivalent to 1/2. Let's try another problem. This time, I want my denominator to be an odd number. Let's do 0/11 plus 1/11 plus 2/11 plus 3/11 all the way to, there go those 3 dots again, 11/11. And I want to find the sum. Who remembers what those 3 dots tell me I need to do? That's right, I need to expand my units because I'm missing several units. What fractions am I missing? That's right. 4/11 all the way to 10/11 is missing from my equation. So let's go ahead and expand my units, this time making sure that I have all of my units represented in my equation. And now that I've expanded my units, I'm now able to add. Remember, when we're adding, my denominator stays the same because all of my denominators are 11, and I'm only focusing on my numerators. If it makes it easier, you guys, you can even chunk these fractions in order to make them smaller. And in order to make sure that you're not adding multiple times if you don't have to. So for example, I can chunk 0/11 to 3/11, and that would give me 6/11. I can chunk 4/11 and 5/11. I would have 9/11. 6/11 to 7/11. I would have 13/11. 8/11 to 9/11. I would have 17/11. And 10/11 and 11/11. And I would have 21/11. Now that we've chunked our fractional units into larger units, it actually makes it easier for us to add. Instead of adding 0 plus 1 plus 2 plus 3 all the way to 11, now we're just adding 6/11 plus 9/11 plus 13/11 plus 17/11 plus 21/11. Go ahead and add your numerators together and let me know what you get. Did you guys get 66/11? Me too. Awesome job, you guys. Now, I know I'm not done, and you guys probably already are working on this now. We have to decompose 66/11 into a mixed number. What's going to go on my left-hand side? That's right. 66/11 is going to go on my left-hand side because I can multiply 11 by 6 and I would get 66. So in this case, I would have 0/11 on this side because I have nothing left over. 66/11 is equivalent to what whole number? That's right. It's equivalent to 6 wholes. So 66/11 is the same thing as or equivalent to 6 wholes. And I don't even need that 0/11. It's equivalent to 6 wholes. That's interesting. Do you see a pattern between the first problem we did and the second problem? What pattern did you notice when adding the sums of fractions with even denominators? So our first problem was a problem with even denominators. Look at what you got as your answer. Our second problem was a problem with an odd denominator, 11. Look at what you got as a final answer. What do you notice about your answers? when you have an even denominator as the sum of fractions? That's right. I noticed the same thing, you guys. I noticed that my answer was a mixed number. What about when it was odd? What did you notice? That's right. I noticed that my answer, or my sum, was a whole number. That's so interesting how we were able to identify patterns within fractional units. You guys did amazing work. Thank you so much for making sure that you were following along with me in this video.